Come light it up, I'm ready to go. Come light it up, come light it up, I'm ready to go. Come light it up,
So my name is Simon Thelin. I work as a lead data engineer at a company called 7bridges. So I've been at 7bridges now for the last 9 months. And 7bridges is a supply chain company. Or rather, what we like to say is that we make supply chains smarter. So, what is this? Well, essentially, a lot of the companies that ship things all over the world, they currently have quite outdated systems, and it can be anything from invoicing to where should I send, where will be the best place to put a warehouse for my shipments, etc. And here's just a few bullet points to try to explain that. So one of the main features, kind of gain a bird's eye view of your entire supply chain, and kind of look beyond what you're currently doing to use your data more accurately. So a lot of these companies, they have a lot of data, but they don't know how to use it, and in some cases they don't have the time to use it. And in general, when we gather all these things, we also have an AI side to the product, where essentially we can do more on the recommendation side, kind of real-time predictions, etc., on where the best shipments. And I'm gonna try to go a little bit more into depth. So this is quite a technical chat. So this is also incredibly overly simplified, but so 7bridges has had a main platform, and in this main platform there's been a main database, a relational database, and all the applications have been talking to this main database, and also the BI reporting has been communicating with this. So very standard setup with a main database. There's a read replica. You scale these back and forth, up and down. This kind of works. It's a very basic setup, and it works pretty okay until there comes a moment where this technology, in this case it's Postgres, it essentially doesn't really scale from a if you want to do a lot of read and writes at the same time, a lot of users trying to do a lot of things simultaneously, it causes a lot of problems. So with that said, we have built out, and this might look a bit overwhelming at first, but it's not really that much. So essentially, what we have decided to do, I'm fully aware of that you can connect Starburst Galaxy to any data source. For us, however, we want to remove as much compute as possible from the main platform's database, so it can be used for what it's meant to be used for. And then we move our data into a more of a analytical format, which suits better for our AI and reporting, and also things kind of in between that. And we use a lot of open source technology. So the whole before I explain these things, a lot of people who are listening probably recognize a lot of the technologies and kind of the approach. So the main thing here is that we work with a Lakehouse architecture, and myself, I worked a lot in the past with data warehousing or data lakes, and they tend to live their own separate lives, and they fit different purposes. And what we do here with the Lakehouse instead is that we combine these two paradigms into the same space, so we can do streaming, batching, reporting, but also AI-driven applications on top of our data. We kind of started out deploying Trino ourselves in Kubernetes. Our team is very, very small. We're not that many people working on these things. So, and I was very keen on working with Delta. So we don't use Databricks, but we use the open source Delta as our kind of main data layer. And I was playing around a lot with during the last year. There's been a lot of gains around Delta and how to connect to it, etc. And Presto has a Delta connector, I believe, and that's how I found out about Trino. And then we started using that a bit for proof of concept, and then we moved on to Galaxy currently. So how all of these components communicate with each other is that a lot of this might be kind of traditional data engineering, but we essentially sync in our data. We have kind of data engineering heavy tools for this if we want to go batch streaming. And then we also utilize, and this is its own compute, obviously. And then once the data is in, we also utilize DBT, in this case, DBT Trino, which is powered by the Galaxy cluster. So not only can we use Galaxy for querying our data for reporting, but we can also use it to do transformations, like either if it's ELTs or traditional ETLs or, whatever it might be. So this gives us a very, very flexible environment where our data is centralized, but our compute is decentralized. So we are not big enough to go full-on data mesh, but everything we're using currently is trying to make sure that we can actually build our own data products. Like backend teams, for example, they can go in and work with this. It's quite easy for them to go in and do some, if they want to write something in Spark, they can do that. If we have some business analysts that don't have the engineering experience, they can go into DBT and, do some quite cool stuff there very quickly. So we can move very fast. We can build very solid foundations. And then on top of that, people can do their own stuff. And so, this is just a high overview, but so this is the state currently. And I was gonna talk about, so Leo is our main AI application, you could say. So this is something that's obviously outside of the main platform. So when I came to 7bridges, the data scientists, they were kind of working with the tools that they had to their disposal, and they were currently running Dask clusters where they were doing all of the data science workloads. However, as you can imagine, communicating with a Postgres database from a distributed system like this is not ideal. So the problem here is that this deployment process, all of this worked. I mean, in theory, it kind of works, but what happened is that, you would have your database, the main platform data would be there. We would make a copy of that full-on database and then replicate that out on each worker. So you can imagine how tedious that becomes from a deployment process. So every time you spin up a worker, it has a sidecar Postgres in Kubernetes, and while this system runs, sure, this solves scalability. You can scale it horizontally, but it's a lot of pain making sure that it's up and running properly. Essentially, a Postgres is single node, storage and compute on the same node, right? So here you're kind of working against the architecture of a Postgres and making it work. And the big problem here was that, sure, it would execute, it would deliver what it needed to deliver. So they would write the outcome of all these predictions back to the Postgres database so that the backend could fetch it and visualize it to the front end. And then they would have another process writing to S3 just raw Parquet, which essentially is not available to query, but just mainly storage, and they could just read it, kind of local storage style. So now with Galaxy, we have a new architecture, kinda, and so I've just tried to provide the full context here. So on the left, you have the main platform. I'm visualizing the upper part where we're doing the daily syncs of the data, and we do this at various speeds. So anything currently between 5 minutes to an hour. And in the first diagram, you might have seen some Debezium, etc. And we were also playing around with CDC, essentially streaming it in. But for now, we have a latency around 5 minutes to an hour, depending on what data it is. And essentially, this data ends up in our what we call a silver layer. We have a couple of jobs in between in dbt Trino at the moment, where a lot of this data that Leo uses, some of it the data scientist decides over, but some other data actually is owned by business analysts. So we need everyone to be able to contribute and modify the source data that Leo needs to do its predictions. And then ultimately, we write it back into the Lakehouse where it can become queryable, not just for Leo in this case, but also for the rest of the platform. It can be consumed by any engineering team in the company. So one great thing with doing it this way instead is that, so we have written our own, so we call it 7B Trino client. So it's based on top of the open source Trino client that Starburst has developed on. And we also have a few tweaks with Delta RS inside that, and I can explain more why and the use case around it. But all in all, what happens here is that we can read the data now from the distributed system, and we can write back very quickly. And we have many different types of loads here. Some workloads are very, very small. Some data sets are very, very tiny, and some others are very, very big. So we need to be able to run distributed query loads when needed. And in some cases, we also need to be able to like work with very small data sets. So Delta and Starburst in this case in tandem gives us that flexibility. So yeah, I can explain a little bit more how our own written client works. So due to the nature of how all of this works, sure, we get all the great query performance, like for the reporting, etc. But on the data science loads, a lot of the data is being created at runtime. So that means that a lot of the times we need to write new tables. We need to create new data sets on the fly very fast, and we then need to get it back into the system very quickly. So currently, if we want to create a data set in memory, which we then write through Starburst into our Delta tables, we kind of mimic what dbt Trino is doing, but in between we use the open source Delta RS library, where we can essentially create a temporary storage, which we write to, and then from there we build our upsert command into the target table, which we then run over Galaxy. And this works pretty well, and this is quite cool because anyone who's worked a lot with Spark, obviously you can do all of these things natively in Spark with Delta, but we can't tell our data scientists to just switch to Spark, for example. So they're very keen on using Dask. So we kind of worked around this, and without, so Starburst has a big part here because Trino clusters themselves, they offer so much flexibility for us to communicate with the Delta layer in a way that, for instance, if we only use Delta RS, we wouldn't be able to do that because it has its own constraints. And then another thing here is when we do reads. So we, in almost all cases, almost all cases use Starburst to read in the client, and this might be some product feedback to get to Starburst itself, not in a bad way at all. But so, like I said before, we have this big variation of some data sets are tiny and some are very big, but we want to utilize Delta to get the flexibility without having to throw around the data all over the place, so that our data scientists can work with it in a coherent way and track the data. have the audibility, etc. So the good thing with this is that they can write a Python application. They can query big data sets. It will be fetched in a distributed fashion over Galaxy on the Trino cluster, and they can do stuff with it on their end. And then in our client, we also have currently, when you run with Starburst, there's a query planner. And for some of our data sets, which are incredibly tiny, essentially it doesn't make a lot of sense to distribute the fetches. We use this deltaRS and DuckDB, but it's in, I would say the ratio here is probably 95% Galaxy and 5% where we utilize DuckDB. But the important thing here is that we have that flexibility. And as a user of Galaxy, so in general, in 7bridges, we want to use the right tool for the right job, and we want to combine things together. It's possible that, it all depends on your use case. But yeah, I just want to show how we use it in an honest way. And other than that, I have a couple of bullet points in general. So, I didn't speak much about that, but the old processes around BI reporting, when they were running towards the Postgres databases, there would be queries there that would run, for 45 minutes, an hour and a half. And as soon as we adopted more of this kind of Lakehouse approach and querying the BI through Galaxy, we've done massive gains. And even in some queries that used to run in 45 minutes, we can now run in under a minute. So I'm kind of just saying here carefully 100%, but there's many cases where it's probably much higher than that. This is crucial as we scale up and add on more clients to answer the basic questions. And also the utility of Starburst Galaxy and our data science workloads. It has simplified so much on our deployment side. Like before, the data scientists had to fiddle with all these Postgres databases on the workers and massive pipelines to do various different things. And now we just have the cluster up. Our client will communicate with the cluster. They can do stuff with it. We can read and we can write. And it's super flexible. So a person who's never worked with data engineering before can just go in and do stuff very quickly. And then the dbt Trino stuff, or maybe not stuff, but the dbt Trino environment for our business analysts is also great because they can go in, they can write SQL, but it can be computed in a distributed way. And that can auto scale in its own way, so that no one has to really worry about tuning, how I'm going to make the distribution work in the best way, etc. So that's what we see as our self-serve. So that's where there is some kind of data mesh inspiration. So a lot of our data products need to come and go very quickly. So with dbt, they can go in, do this very fast, show it to a client. If they like it or don't like it, you can tear it up and down. It gives a lot of flexibility. And yeah, I think that's it really.